Just had two young ladies right before class saying, at one time I needed the video, you didn't have it? So if that happens to you, just send me an email. You can send me like, well, I shouldn't even say that to you. Just send me an email and I'll get that up there. Because as far as I know, I have every single one up there. I must have missed one or two, but let me know. Today we are doing 4.6, completing the square. Now, of course, these first two problems have nothing to do with completing the square or a very loose connection. So, if we're looking at this, we're reading the directions. What is the solution of each equation? We see that we have x squared, meaning we have two solutions to the equation, so we get to solve for x. We do that by subtracting 10 from both sides, and we get 4x squared equals 36. Then we divide both sides by 4, and we get x squared equals 9. The only way to undo a square is to take the square root. So we're going to do that to both sides of the equal sign. Make sure you put a plus or minus in front of the number. So square root of 9 is 3, so we get x equals plus or minus 3. Many students will ask, well, why do you need the plus and the minus 3? Here's why. We take negative 3 and square it, we get positive 9. We take positive 3 and square it, we also get positive 9. So those are the two answers that work. Right? We can plug in negative 3 for this x right here, and get positive 9, or positive 3 and still get positive 9. The B problem on the right side here, again, we're just solving for x. You know to do that because you see that solution. So we're going to add 5 to both sides, and we get 3x squared equals 30. Then all we got to do is divide by 3 on both sides. We get x squared equals 10. So not everything, you can't square root everything, right? So if we just square root both sides, plus minus, we get x equals plus or minus the square root of 10. So if you can't evenly take the square root, you can leave it like that. Now, however, if you can break apart the square root of a number into factors of that number that you can evenly square root, you must do that. I'll show you what I mean in the next couple examples here. But let's just look at square root of 10. So you guys know how to find the square root button. You hit second, x squared. And then if you just throw 10 in, hit enter. You see this is an irrational number, meaning the decimal does not repeat. It's a bunch of random numbers after. So square root of 2, square root of 3, square root of 10, square root of 5, those are all irrational numbers, just so you know. So we're going to break apart square roots now, okay? Just so I show you how to do this. You should have spent some time freshman year doing this. If you didn't, if you're in my class, you definitely spent some time freshman year doing this. I'm not sure about other classes. But I want to think about factors of 8 that I can square root, okay? So if I think of factors of 8, I can have 1 and 8 or 2 and 4. So which one of those factors can I square root? Show me at home with your fingers. Which one of those factors can I square root? Yes, trying to make you active participants in the class. So it's square root, square root. Square root of 4 is 2. Square root of 2 you cannot do. So square root of 8 breaks apart into square root of 2, or 2 times the square root of 2. So what I'll do to normally show this, like if I'm just breaking it out, I show it like this. Square root of 4, square root of 2, kind of breaking it out like a little tree diagram. Square root of 4 is 2, square root of 2 can't do anything with, so just leave it alone. So you might look at 32 and think, oh, I can square root 4, 4 and 8 works. Yes, it does, but there's a bigger factor you can square root. So what I recommend is using the old y equals thing in the graphing calculator, 32 divided by x, second graph to see the list of factors, and then I can just copy this list over. Right, I only need to go that far. So what's the biggest one of those factors I can square root? 2 and 16, right? So if I break this sucker apart, I always like writing the one I can square root first, like I said. Square root of 16 is 4. Square root of 2 I can't do. So 4 times the square root of 2. Try 72 on your own. Don't use 4. Don't use 9. Those are not factors of 72 you can square root, but there's a much bigger one you can square root. So give that a shot on your own. You can do seconds, do y equals 72 divided by x to see the factors like that. Once you're done in person, put your hand up so I can double check. You're done? Point to where it is, see that's kind of helpful. Good. Smoke coming out of their ears in person. Good stuff. That's it. Yeah. So just 72 divided by x. The other one, so yeah, second graph. And then it goes back up, so you get the 0. Yep.
Hey, Evan, I have a question.
Fire away.
So when you do the, like, after that, you get all, like, the, what equals 72?
Yep.
Do you do the highest number, like 2 and 36, if I do that?
Exactly. Biggest one you can take the square root of. So yes, you do want 2 and 36. So if I break it apart like that, square root of 36 first, square root of 2 second, 6 times square root of 2. So as students were working on their homework, they were asking, like, they ended up with square root of 8 as part of one of their answers. They said, should I break apart the square root? Hell yes, you should break apart the square root, always. Every single problem you ever do for me, always reduce, simplify to its most basic parts. If you go too far, I'll tell you, but it's very rare when that happens. I don't want to do either of those. Let's do this one. So, solving a perfect square trinomial equation. Get in the habit of reading the stuff next to the problem number 3. It will help you understand what the heck's going on. This thing is called the perfect square trinomial on the left side of the equal sign. The reason it's called the perfect square trinomial is because we can take the square root of the a term, we can take the square root of the c term. So the square root of 4 is 2. What's 2 plus 2? 4, right? And when I take the square root of the c term and I add it up, I get the b term, perfect square trinomial. You can square root a term, you can square root c term. When you square root c, you add it twice and you get b. Okay, so we have to factor this perfect square trinomial. Don't write what I'm about to write. You can write the next step below. So this technically factors to 2x plus 2, so x plus 2 and x plus 2. Don't write it like that. The whole purpose of factoring this is to go from 2 x's up here to 1x right here. Because as soon as I get to a single x, I can solve for that single x. Up top, I can't solve for it because I got too many x's. Okay? So, all we got to do is take square root, both sides, put plus or minus in front. When you square root a square, the square goes away. So we just have x plus 2 left on the left side of the equal. Square root of 25 is 5. So we have plus or minus 5. So many people at this point want to subtract 2 from 5. You can't do that because the plus or minus is in the way. So just subtract 2. Just calm yourself. It's all going to be okay. Then we have x equals negative 2 plus or minus 5. So when I think of this, I do negative 2 plus 5. And then I do negative 2 minus 5. Like that. So if you instead want to write out these two steps, you don't have to, but if it's going to help you get a problem right, don't be lazy, just write the thing out. And your answer is 3 and negative 7. Right? If you subtract the 2 from the 5, you only have one of the 2 correct answers. One of your answers would be wrong, one would be right. So that'll happen too. It doesn't happen a whole lot where you can square root the right side of the equal, but it'll definitely happen. So don't stress out about that. We got Captain Neal coming to observe this class tomorrow, and I had an easy lesson to teach you. I don't want him to see an easy lesson. I want him to see a nasty one. So I'm going to teach you the nastiest lesson of this chapter. He didn't think anything was nasty so far. We start dealing with negative square roots or imaginary numbers. So I want to be able to teach you that because he'll be amazed at how quickly you guys can get it because you're all so smart, of course. Okay? Duh.
Isn't imaginary numbers actually just all like real problems?
Yes, it is. It's so imaginary. Henry said in Pearson, aren't imaginary numbers used to solve real math problems? Yes, they are. So mathematicians have to figure out how to deal with negative square roots, and using imaginary numbers, you can deal with negative square roots and still get a common sense answer. Okay, we're going to do this one next. It's a perfect square trinomial again on the left side. So the way I view this is it's like halfway through completing the square. When we complete the square, what happens is we're going to create that C term that will square root evenly. And I'll show you the process on, I think, the next example. It might be one more after this. But square root of 49 is 7. You bring the negatives from the B. Remember, square root of 49 is 7. So if the C term is positive, the signs have to be the same. So this is the same thing as saying x minus 7 times x minus 7. Negative 7 minus 7, negative 14. Negative 7 times negative 7, positive 49. So this equals 25. Square root. Now, can anyone who hasn't finished it yet do that in your head? Yeah, good. Just, I want you thinking ahead like that. Think what the answer is in case something goes wrong. Like you'll see when I make mistakes in class, all of a sudden I'll kind of look at the problem. I know something's wrong. I'm not sure what yet. And again, that's because I'm thinking ahead along the way so I can correct my mistakes if I make them. Because you'll make mistakes just like me. So square root both sides on the left. We just have x minus 7 equals plus or minus 5. Add the 7. So it's 7 plus 5 and 7 minus 5. Again, so I'm kind of always thinking ahead like that. I don't care if you write out the next step or not. You could just say x equals. Tell me what it equals. 12 and 2. So doing kind of half of completing the square is what we're doing now. And this is moving on to full completing the square. So write this down first, including this stuff over here, with the C term on the right side of the equal, because that's what we want it to look like right away. Sometimes I'll already have that C term on the right side of the equal, so you don't have to do anything magic when that happens. It'll happen. So next thing I'm going to have you do, I'm going to show you the book directions for completing the square. I want you to try to read and understand those book directions. Okay? So we're trying to build your capacity to read the math language, because when you take SAT, it's like math language coming out of your ears. It'll make you crazy. So, you're going to love this. So try to read and understand. So those directions aren't too difficult to understand. What I want you to think about as you look at these directions, we have two different formulas that are close in this chapter. We have this one, and we have, here's the other one. So many students mix these up. So this one, the first one, b over 2 squared, is for completing the square. Right? This one is for axis of symmetry and or x value of the vertex. Okay, so you've got to keep those two straight, because it's really easy to mix them up, and then it just makes your life a nightmare. No need for that. Life's hard enough anyways. Okay, so back to our problem. So we have to get that C term on the right side of the equal. We do it by adding 9. No big deal. Then we're going to make it look like the blue writing. So we get x squared plus 4x, blank space, equals 9, blank space. So now we need to do the b over 2 squared. Since you guys looked at those directions, again, I'll read those directions. I have to read them and figure out how to do the problems. Like the first time I taught Algebra 2, like 15 years ago, I was like, I don't remember how to do this. I had to read those directions, figure it out, and then translate it so you guys could learn it. It's just kind of cool, the process to figure that stuff out. So we're doing the b over 2 squared thing. I like squeezing it in on the left here, using parentheses each and every step of the way, because if you don't use parentheses and we're dealing with a negative number, you're going to screw that up. So you want to add 4 to both sides, and that 4 came from the very end. So b over 2, b is 4, 4 divided by 2 is 2, 2 squared is 4, plus 4 plus 4, both sides of the equal. The left side factors, right, perfect square trinomial, that's what we just created. So those previous examples, that's kind of where we're at right now. So I think square root of c term is right here. Square root of the c term is 2. So I can just make this left side x plus 2 squared, like that. Think what the answer is in your head right now. You should be able to finish it in your head. Not every single one of you, but most of you. Again, plan in the head like that, right? So I'm going to square root both sides. And if you thought negative 2 plus or minus the square root of 13, good job. And we'll show you the steps. So we have x plus 2 equals, I forgot plus or minus. Don't forget plus or minus. So what I was saying to fifth period, you guys should know yourself by now. If you're the kind of kid who's forgotten little negatives, made those little irritating mistakes that make you want to scream, first of all, stop making them. Second of all, like highlight, put fireworks by this, whatever you can so you can remember the plus or minus in front. Last step, just subtract the 2 from both sides. And final answer, -2 plus or minus square root of 13. That is what I call, the book calls, any math teacher calls the exact answer. Right, because square root of 13, 13 is a prime number. If I square root it, we're going to get some decimal, irrational answer. So let's say the book wanted you to give a decimal answer rounded to hundredths. I will never ask you to do that because the exact answer is better, but just in case it happens, so you can see it, you just go to -2 plus second x squared, 13, and you can see the decimal keeps going forever, so 1.61 rounded to hundredths, and then I can go second enter, and just go back and switch the plus to a minus, hit enter, -5.61. So 1.61, -5.61. So you can see you're leaving out all of the stuff on the right side there. So that's why that is not exact. When you round, it's not exact. When you leave the square root alone, it is exact. Okay, write this one down. And we want it to look like that. Ax squared plus bx with the blank space equals c with the blank space. So if you feel like you know how to do it, jump ahead and crank it out. I'll go kind of slow on the steps to make sure everyone else gets it. First thing I got to do is add that 12 over. So I get x squared plus 10x, blank space. I always get a kid or two that hate that I write those blank spaces. To you, I say, get over it. 10 over 2 squared, right? That's a b over 2 squared. b is 10. 10 divided by 2 is 5. Squared is 25. That's what I'm going to add to my blank spots. So if I want to know what it factors to, I can just look one step up right here. Right? So this perfect square trinomial factors to x plus 5 squared. 12 plus 25 is 37. Again, as soon as you can challenge yourself to think ahead of what the answer might be, do so. Right? You're just making yourself smarter by doing that. There's not many people who want to get stupider as they get older, right? We're all trying to get smarter, learn, learn, learn. Even me at age 52, I love learning still. Right, so I get x plus 5 equals plus or minus square root of 37. 37 is a prime number. Right, so the only numbers that multiply to give you 37 are 1 and 37. Good exercise we've done in the past is to try to lift prime numbers as fast as you can. It'll kind of make you crazy because you got to do a lot of thinking along the way as you do that. So x equals -5 plus or minus square root of 37. Done. Okay, I'm going to make one up for you. I want you to try on your own because the next slide, that's what I thought. I was going to have students try on their own. But if the b term right here is an odd number, We're going to do that example after you guys try one on your own. You'll be amazed at how much more complicated this gets. It can get just so horrible, I can't even begin to tell you. But I'm not going to do that to you just yet. Okay, so try that one completely on your own. If you're in person, you can raise your hand if you get stuck. You could do the same thing if you're online, just like hold your paper up to your camera. Remember, you guys, those of you who don't have cameras on, unless we have a previous arrangement, which is only one of you, I will find a way to punish you for not having your camera on. I will punish you in a way that's so creative you won't even know, but it'll result in unhappy moments for you. Right, so I want you flipping back and forth in your notes, like looking at a previous example, trying to figure it out. And as I said, if you get completely stuck, I can help you. You got to break apart that square root of 12 as well, right? A good challenge for those of you that totally get it, try to do the entire thing in your head. That's what I'm trying to do right now. It's kind of fun. Now, most normal people wouldn't think that's fun. That's maybe a math teacher thing. Definitely a math teacher thing, but, you know. I'm going to tell you the answer, just so you know the answer. You should get, and again, this is me doing it in my head, so hopefully I'm doing it right. Negative 3 plus or minus 2 times the square root of 3. Good? Okay. So I'll show you guys, those of you that got some puzzles along the way, how you do this. So we're going to add 3 to both sides. So we get x squared plus 6x, blank space, 3 blank space. B divided by 2 is 6 over 2 squared. 3 squared is 9. So I'm going to add 9 to my blank spots. Notice how I add the 9 in a different color, because it'll help you to figure out what the heck you did. So this factors 2x plus 3 squared. Again, realize that 3 comes from right there, right? One step above the 9. That's how you can know what that thing factors to. 3 plus 9 is 12. And we just take the square root of both sides. Don't forget the plus or minus. X plus 3. I'm going to break apart square root of 12 right now. Plus or minus square. Maybe I'll show that off to the side. So 2 root 3. And then last step, just subtract the 3 over. So let's say you didn't simplify the square root of 12 on this problem. I just take a half point off, that's all. There you go. Okay? Raise your hand at home if you got it right. Okay, in person? What, can you tell me what you did wrong? Are you comfortable doing that? Is that okay? Sam? Yeah. So multiply it on the right side, right? By accident, that can happen for sure.
I did almost exactly.
Okay. Okay. Did you get it?
kind of, I just kept it to 12 instead of.
Okay. So a couple people didn't simplify square root of 12. Just know, me as a teacher, by now you should. Like if you don't simplify or reduce a fraction, you know I'm going to take points off. So if you're asking, like, should I round? If I don't tell you to round, just round to hundreds. That's a good kind of fail-safe. All right, so now we have one with an odd B term. And you'll just be mildly impressed of how this thing works. I can just disconnect it in mid-areas. Okay. So, half of B squared. Don't make it a decimal. You got to deal with fractions. So just deal with it. It's all going to be okay. When I square a fraction, I square both numerator and denominator. 7 squared is 49. 2 squared is 4. And I wrote 2. 2 squared is 4. So that's what I'm going to add to my two blank spots. 49 over 4. Okay, so we just created a perfect square trinomial on the left side. So here's where it's important to look at the step before you square, because this left side just factors to x plus 7 over 2 squared. So again, that 7 over 2 just came from right there. Okay, so you don't have to like tax your brain. Now we have to add that whole number 11 and 49 over 4. When you're getting a common denominator, if this one's over 1, you're always, so every one of these completing the squares with an odd B term, you're going to multiply by 4 over 4, every single one. So we end up with 44 over 4 plus 49 over 4. When you add fractions, add the numerators, leave denominators alone. So what we get here is x plus 7/2 squared equals 93 over 4. So right, just because there's an odd B term, this happens. You've got to deal with all these fractions. But once you get used to it, it's still not that big a deal. So that's a little trick. You can square root both numerator and denominator. The reason I want to write a square root in the numerator and a square root in the denominator is because I can take the square root of 4. So we end up with x plus 7/2 on the left side of the equal, plus or minus square root of 93 over 2. Last step, subtract that 7/2 over. So we get x equals negative 7 over 2 plus or minus square root of 93 over 2. That looks exactly like the quadratic formula. When we do, we'll do the quadratic formula probably on Friday. Quiz on Thursday. No, that's not true. I'm doing quiz on Friday. So take it back. I just changed my mind in a second. I have somebody in person looking at me like, what's wrong with you? And to that, I always say, a lot. But, you know, I can still teach, so that's good. That's it. There's your homework. Quiz on Friday. It's going to be over 4-3, 4-4, 4-5, And it'll be 4 sections, and then we'll do it on complex numbers, imaginary numbers. We'll learn tomorrow. It's good times. You're going to love it. Right? If you get stressed out, I would say that, right? Yeah.
Do you want to help me with something real quick?
Sure.
Okay, I used to tutor this girl after school in math, and we're doing fractions, and I just have no idea what I'm doing. So
Okay.
I'm not fractions.
You want to write some on the board?
Yeah. I'm serious, I just have no idea what I'm doing.
Are you getting paid?
Fifth grade.
Are you getting paid?
No, it's for Spanish Honor Society.
Uh.
She's in 5th grade, and we're doing, like, long division, which is fine, but then we're, like, now doing fractions, and I'm just like, oh.
How does it work? Yeah.
Right, we multiply.
No Malfoy today, Hannah?
Like, so.
No Malfoy? No.
I forgot until this moment that I did not put him behind me, so.
Oh my God, it had to happen once.
Yeah.
It's all good.
Do you just multiply across?
Straight across, top and bottom. 60.
Okay, well,
And then still reduce that, right?
oh, you're so right.
Especially for her, just say they're both even. Like you get this one automatic. I don't know if she'll know that automatic.
Oh,
You just
yeah.
cancel zeros on the end. And then they're both even reduced. That's like the easiest way to reduce. Yeah. So you guys remember these problems. First one, first group, you're just solving for x. Second group, that's where you just factor left. So factor left, and then solve. And then the 3 problems at the end, that's full completing the square. Sometimes students will try to complete the square on the early ones and it doesn't work. You forget about the first example I taught you.
All right.
Yep.
Yeah, all right.
So here's another thing, if you can handle this. I love doing it like this. 4 divides into 12 3 times.
I remember learning that.
And then you can't do this one. So 9 over 13. Right, this one.
Cool.
5 divides into 10 2 times. 4 divides into 12 3 times. So if you can handle that, you skip like a couple of steps. Just depends how smart they kid is, whether or not they can handle that or not.
What is this? How do I do that? Number 7?
Is that 10 to the third?
It's 10 to the first, second, and third. It's 3 different
So
problems.
it's just times 10, so you're moving the decimal 1 time.
Okay.
10 to the second 2 times.
Oh.
10 to the third 3 times.
That's easy, okay.
See? And you say it just like that to her, and she goes, oh, yeah, that's not bad. Oops, I didn't